All right, folks, we'll get started. Welcome to the final session, the final time slot of the conference. We hope you've had a great conference so far, and we'll try to finish it off on a good note. We're super encouraged by how many of you are here. When we found out we got the last time slot in the conference, we were like, will anybody be here? So thank you for coming here. And just as a quick level set, how many of you are writing code today against Azure Storage? Okay, many of you. Awesome. So we're going to do a sort of a three-part talk here. We're going to do a quick overview of Azure Storage and all its capabilities, show you a bunch of code, show you how to get started. We're then going to talk about storage from the DevOps perspective and how you keep your service running. And then we'll end with design patterns, both existing ones and new design patterns that we've added since the last set of conferences. So let's first get started with a short video as people come in. Of course, the session feedback, please don't forget to do that. We'll leave this up at the end of the talk. We really appreciate your feedback and comments especially. So do let us know. That's how we improve. Let me just start this off.
The Xbox Live service powers a lot of the social experiences on the Xbox console. Things like competing with other players, playing with other players in the same game, either cooperatively or competitively, and then also tracking your progress. We hope that by providing these social features or these challenges features or things that kind of go beyond the gameplay, that we're able to give you a much better, more enjoyable experience when you're on our platform. All of our services use Azure Tables for their base layer of figuring out where a storage account is located. So at the end of the day, you use an Azure Storage account for your blob and table storage, but we use many of those for each service. And we do that because we want to be able to get more of that elastic capacity out of Azure, and also because we don't want to pull all of our data in one place for things like disaster recovery purposes. So every service in Xbox Live uses a common platform based on Azure Tables to figure out where each user's data is stored. Xbox, when we ship a new feature, millions of people use that feature almost instantaneously, and that's a significant amount of load that we've spent the last 10 or 12 years trying to figure out how to handle and scale for. And as we moved to Azure Storage, we were concerned that could this partner service do the same thing that we were already doing internally? And it was fantastic that it could actually do that. We've never seen an issue where we deployed a new feature and Azure was the bottleneck that caused us to not have that feature work. As we look to the future, we want to be able to get things done faster and try things out more. And we're going to make mistakes, but we're also going to do some really great stuff. And the faster that we can iterate on these things, the faster and more likely we are to make our customers happy. We want Xbox to always feel like the best place to play games. And that doesn't just mean that we have the best games, but that also those games are more fun on our platform. The more and more data that we can push through the system and the more data we can retain and massage and process, the easier it is for us to light up those experiences. And that's really something that Azure helps us do. We don't have to think about how many more servers we have to buy to do this or how many more hard drives do we have to buy to store all this stuff. We can just know that almost infinite capacity will be there, and we can build almost anything that we imagine to enable those experiences.
Great. So this is the story of how one of our earliest partners, when Xbox was building Xbox One, they decided to bet their business on Azure and Azure Storage. And now pretty much anything you do with your Xbox runs through Azure. They run hundreds of thousands of cores, run petabytes of data through our system. And it's fair to say, you can't really turn on your Xbox without touching many parts of Azure. And this is true across the Xbox set of services. So it's Xbox Live and your social graph, your friends, your achievements, activities you've taken, all of that ends up in table storage. Game DVR, you record game clips, that comes into Blob Storage. It's encoded via Azure Media Services. Xbox Music and Video, the master catalogs, the encodings, everything is stored in Azure Blob Storage. So this is kind of just a short set of the features that run on Azure Storage Blobs and tables. So this is kind of our journey and figuring out how to help our partner and internal Microsoft teams run first and best on our platform so we can get that scale and then bring that to our partners, our developers, all of you. And we'll talk about this and talk through how Azure Storage can really get you there. So the first thing to start with is our infrastructure scale. Right? We're well over 1 million servers today. We're in 19 regions, more than both AWS and Google combined. India is our newest announced region, and we have in many other regions as well. Azure Storage is in every single one of these regions. It's a foundational building block along with compute and networking, and every other Azure service and many Microsoft services build on top of it. In terms of our own scale for the storage system, we have well over 50 trillion objects in our system. We do 6 million transactions per second average on our system across the world. And if that's a hard number to wrap your mind around, it's basically 1 billion transactions every 3 minutes, right? That's happening all the time. In the 2 or 3 minutes you heard that video and got to this slide, we've done 1 billion transactions in our system. We're also, really focused on being the most open platform for getting your data, regardless of what device or architecture you're coming from. We have REST APIs, of course, but we've also built client libraries in .NET as you'd expect, but Java, C++, Node.js, Android. We just launched a Xamarin library preview. We're working on an iOS library, and we have Python, Ruby, and PHP as well. So our goal is really to abstract all of the, it's not fun to go build REST transactions, so we want to go do that, give you a good standard offering that you can then depend on regardless of what platform or device you're building on. We're also really good at doing sort of that hybrid storage between on-prem enterprises and our cloud. The Azure backup and disaster recovery services, Azure Site Recovery, run on top of Azure Storage. You can have a really nice connection between all your on-prem machines and VMs, do backups, do disaster recovery, restores into the cloud. We also have Store Simple, an offering that allows you to build enterprise-tiered storage that then gets sent very efficiently and stored in the Azure Storage Cloud. We have a number of different data offerings, a number of different abstractions ranging from unstructured storage to NoSQL, reliable queuing, and persistent disks. We'll kind of walk through each of these and going to give you a quick overview on how to code against them or how to use them. So let's start with the base layer, blobs. So blobs, and for each of these abstractions, I sort of have the one-line summary you can walk away with. In the case of blob, it's highly scalable, REST-based cloud object store, right? It's where you'd store files. What you canonically think of storing in storage, you would store it in blobs. There are two kinds of blobs. There are block blobs that are meant for sequential reads. So it's where you'd upload files, download files. It's typically what you would be using. There are also page blobs, which are optimized for, they're sparse files, they're optimized for random access, and they actually form the backbone of Azure Infrastructure as a Service data disks. So let's start by kind of jumping right into code and seeing, hey, how do I get started working with blobs? We'll go over here. We'll start with Visual Studio and open up a new project. The first thing you notice once you install the Azure SDK is you have this cloud and quick starts in here. Data services. There's quick start samples for blob storage, tables, and queues. So we'll quickly run through those. So let's say I'm going to go ahead and start this up. So getting a new project going. And I'm going to open up the program. Zoom in a little bit. All right, so right away, I'm just going to start. Hit F5. The first thing it's going to do is going to go get the NuGet package references and restore them, and we're up and running. So we're doing some blob operations. We'll talk about what containers are, block blobs are, and we're kind of doing block blobs and page blobs. And the sample kind of gets you up and running right away. This isn't running right now against the cloud. If you notice, it says, dev store account 1. This is the storage emulator running on your box. So you can get started and run your tests, run all your experiments without actually connecting to the cloud and paying for transactions and all of that. So you can get started right away, even offline right now in this room with no problems at all. So let's start kind of modifying this and looking at what we can do here. Right? This is a pretty straightforward, simple sample. We'll look at what it does and then start modifying it a little bit. So here's my main. I have some block blob operations. I have some page blob operations. So let's jump into the block blob operations. I have an object that I'm working with here. Let me go ahead and exit here. So the first thing I'm going to look at is, what's in here. I have an image that I'm working with I'm going to upload. I also then have an object hierarchy starting with a cloud storage account. And that's something that goes in and reads a connection string from app config. We'll go take a look at that. We then have a blob client that we create on the storage account. We have a container that we create on the blob client, right? And all of these so far are offline operations. This is the first operation that actually tries to connect either to the emulator or to a storage account in the cloud. A couple of things to notice. All the code in the samples is async. We have async and sync APIs for all our APIs. We strongly recommend, of course, that you use the async APIs. This is kind of a way to look at this. So let's kind of start by taking the storage account, actually, and opening up app config and connecting this to the cloud. So here's my storage connection string. It says right now, use development storage equals true. I'm going to replace that with a connection string for a demo account that I've set up already. And what this shows here is a couple of things. One, you have the protocol endpoint. You would typically set this to HTTPS. The only reason you'd set it to HTTP if you're doing development work and you want to debug this, makes it a little easier to work with a network trace or Fiddler or what have you. You have your account name, and then you have an account key. Okay? So we've set that up. We've saved that. Let's run this again. And now, as you can notice here, I'm running against the Azure cloud. So this is live code running. We've connected to this account, demos 15, and we've gone ahead and done some operations here. So let's look at what operations we were actually doing, right? So we've kind of connected. We've created a container. So the object hierarchy or the data hierarchy for blob storage is you start with an account, which is kind of your container for all data. Then you have a concept of a container. Think of it as a directory, if you will, that you can set isolation things on. You can set shared access signatures, which allow you resource isolation. You can do atomic operations against the container, like dropping everything in it. And then you store blobs inside these containers. So we create the container if it doesn't exist. We then go ahead and upload a blob, right? So we go ahead and get a blob reference with our image that we're uploading, and we upload that. So with a single API, you can go ahead and upload. I then go ahead and list all the blobs in that container. I download the blob again, and then I delete the blob, right? So I'm just trying to clean up. So I'm going to go ahead and comment this. Oops. I'm going to go ahead and comment this out here. So we don't clean up the blob. And the other thing I'm going to do is I'd like to access this blob once it's created. So in the sample code is this little note about saying, hey, if you want to set the container to be public, you can go ahead and do that. So I've just uncommented that line of code. I'm going to go ahead and run this sample again. And at this point, I should be able to see the blob. And I'm going to show that to you a couple of different ways. The first, of course, is just, let's go look at it in a browser. So simple enough. I can reach it. It's public. But if it weren't public, I can also look at it in Visual Studio. With the SDK, you get a nice little storage explorer built in. So I can open up storage here, open up the demos 15 account, and I can open up the blobs. And let's go look at our demo container, blob that we created. And here it is. And it is UTC 915. So we're looking at this, and we can see that even for a private blob, you can kind of go through and browse things as needed. Close that out here. The other thing that we want to do is, obviously this being a sample, we don't have a lot of error handling here. In a production code, you'd have exception handling. You'd be looking for common exception codes and things like that, catching them and doing something with them. So I'm going to quickly insert a small snippet of code here and talk through what that allows me to do. So let's take this upload block blob line and then replace it with my code. And what this code does is two things. The first thing it does is it overrides the operation context client request ID. The client request ID is a field that the client library automatically generates for you and gives you a GUID, but you can override it with anything you want. And the reason you'd want to do this is typically a request for you is maybe a set of transactions to storage, and you want to tie them all together and look at them as one entity when you do your DevOps story. So in this case, I've just sort of said, hey, my client request ID is this string. And the next thing I'm doing is adding a little bit of exception handling around here, right? So I'm trying to upload the blob, and if I have a problem, I'm just going to catch the exception and log some information here. So let's go ahead and run that again. Oh. Let's see where we are. So I forgot to add a reference here. And what that was doing, basically, even though it's in sort of the wrong place here, is taking care of Service Point Manager. The default connection limit is something that allows you, the default connection limit for .NET is 2 connections. If you're trying to do, it doesn't matter much for this demo, but if you're trying to do a lot more data, you want to set this a little bit higher. Use Naggle is very useful for tables and queues especially. If you have small entities, Naggling tries to aggregate data together before sending out packets, and it's really hurts performance when you're dealing with small amounts of data. So let's try to compile that. Okay. It's gone ahead and run. And you see here, though, it's also failed, right? Because I commented out the blob deletion, I got a 409 error back that said, hey, this blob already exists, right? And we give you a friendly error code, we give you a date timestamp, and we give you this thing, which is a server request ID. And that's a unique ID that the service generates and sends back to you. And this is also useful, as we'll see later in our demo. We'll take this ID and use it to do some debugging. All right? So let me get rid of that. Let me copy this out. All right, so I'll just save that for now and get out of here. So coming back to our presentation, okay. So that's kind of a quick overview of how to use block blobs. And I think the big takeaway there is you can get started very quickly, very easily with these quick start samples, and you can explore and kind of branch out from there. So let's talk about tables. Tables are our NoSQL offering. They are used anytime you want to store semi-structured or structured data. And they're really about storing schemaless entities. The big feature that we give you is we do dynamic load balancing. There's no real limit on the number of rows or the size of a table. You can grow as much as 500 terabytes, which is the size limit on account. And we take care of observing which regions of your table are hot, getting a lot of writes or a lot of reads, and we load balance automatically across hundreds of servers in our service. So you never have to worry about, what's my scale unit, how do I do this? The other thing that we do is provide entity group transactions. If you're trying to do grouped transactions atomically, we do have that within a partition. Do note that we're a key value store. So we're really optimized for key value lookups where you provide us the partition key and the row key. And there are other data offerings in Azure if you're trying to do something more interesting or richer. The value add of tables is really enormously high scale and also enormous, great cost efficiency if your data pattern fits what we offer. I'm going to come over here and show you a very quick preview of table storage, mainly to point out that it looks and feels exactly like blob storage. So you have here, right. So again, I have the same lines here, and like I said, Nagel is more useful here. But let's look at what we're doing. The table async does the same thing, starts with the storage account, gets a table client reference, and then goes ahead and creates the table if it doesn't exist. The table operations, for tables, you need to have a entity, a table entity object. So in this case, we have a customer, and we've inherited from table entity. And that allows you to specify partition key and row key. That really are the indexes we allow and what you do your lookups by. Coming back here. So inserting, we're doing an insert, and actually an upsert here, an insert or merge. We go ahead and retrieve that entity, and we delete the entity. Again, just as simple as operating with blobs. Let's go ahead and run this one as well. And you'll see it does a couple of other things. It also does batch inserts and batch retrievals. So that's kind of, just generated a little bit of load for the purposes of our DevOps, right? So let's go back to our presentation. Queues are a reliable messaging system at scale. Right? Queues are really useful when you have other Azure services that you've built, and you need to decouple your components and be able to scale them independently. So if you have your canonical sort of web role, worker role, you'd want a queue in between them so you could hand off work asynchronously to the workers, and then your web role can scale independently for worker roles, right? So you use it for this. You also use it for scheduling asynchronous tasks or building any kind of workflows. Queues allow you to guarantee that work gets done. So one feature that we have is something we call message invisibility timeout. And basically what this means is once you dequeue a message, you can only dequeue it with a timeout. If your worker crashes during processing of that message, your message will reappear in the queue for another worker to pick up and complete. We also provide an update message functionality, so you can periodically checkpoint your progress from a worker. So if you crash midway through a complicated process, you're not starting over all from scratch. So those are two kind of interesting features to look at with queues. I'm not going to run the queue demo. It looks pretty similar to the blobs and tables demo. So there's a sample there for you to go and play with as well. So blobs, tables, and queues are sort of our PaaS offering, if you will, for Azure Storage. This is what you'd code against. These are the things that allow you to build your services on top of our data platform. I'm going to leave you with this slide. I'm not going to go over it here, but it's a good reference slide. There's a nice little architecture, clean, consistent architecture of APIs and their access. We have a set of APIs at the service level. For blobs, you have containers. For tables, you have tables. Queues, you have queues. And then you have APIs that manipulate either blobs, table entities, or queue messages. Right? So it's a very consistent programming paradigm. If you're using one, it's very easy to incorporate the others into your application. So you're programming against blobs, tables, and queues, but you're probably also bringing other parts of your stack to Azure. Right? You might be bringing a MongoDB cluster. You might be bringing a Cassandra instance. And you're probably going to run them on Azure Infrastructure as a Service, either Windows or Linux VMs. We also provide the backing storage, the persistent data storage for Infrastructure as a Service VMs, both for your operating system disks as well as any data you persist. So VHDs and disks essentially are backed to page blobs that we talked about earlier, optimized for random access. The nice thing here is you get 3 synchronous, strongly consistent copies of your data when you write to an Azure data disk. So you don't have to worry about redundancy and things like that. Every write, when it's committed, is committed to 3 different physical locations. You can always stripe disks together for more performance if you need it. And premium storage disks, our newest offering that just GA'd last week, allows you to build really scaled up workloads. So let's take a quick look at premium storage disks. They're really useful if you're trying to have a workload that needs very, very consistently low latency in the single-digit milliseconds and very predictable high I/O throughput. With the new class of VMs, the DS series VMs, you can do as much as 64,000 IOPS off of a single VM, 32 terabyte of data, and 500 megabytes a second of disk throughput. Again, here with premium storage, even though it's an SSD-based offering, you get those 3 strongly consistent copies. So you're not needing to worry about data durability. Because it's a provisioned offering, you buy it a little bit differently from basic blob storage. You kind of buy it in units of 128 gigs, 512 or 2024 gigabyte disks, and you have different performance numbers for each one of those. Files is another interesting offering. Azure Files allow you to get shared access disks, right? Shared disks. So the data disks are persistent. They're attached to a VM. They're essentially like a hard disk on that VM. With files, you can say, here's my SMB share that I can net use or mount in Linux and just have it work across many VMs and have all the canonical things that you expect of shared disks just work. Right? It's natively supported by both operating systems, and it just works. It's built on top of SMB 2.1, and there's no limits, again, on the number of shares you can create in an Azure Storage account. Each share can be up to 5 terabytes in size and about 1,000 IOPS per share. So this is really useful if you're bringing legacy code bases onto Azure and you needed a share for configuration, for logging, for data, whatever. Right, so that's something else to consider when you're porting your code. Other complementary Azure data offerings, we just heard about Data Lake, which is big data analytics with an HDFS interface. They're building on top of Azure Storage as well. So all of the data that you store into Data Lake eventually comes to Azure Blobs. DocumentDB, if you're more interested in a JSON document store instead of in the NoSQL family, you want to look at DocumentDB. And of course, you're interested in full-blown relational databases. Azure SQL DB gives you a great offering that's a managed database. And finally, if you're looking at queues but say, I need a little bit more rich queue offerings, like PubSub, in-order delivery, things like that, you may want to look at Service Bus. So Azure Storage, kind of the architecture of storage is essentially built on top of one common platform. Right? We have one distributed file system, massive distributed file system, tens, hundreds of petabytes of data in each region. And you have a scale-out layer and a load balancing layer on top of that. So that, the replication layer, we call it the stream layer, is where the data is physically stored. And the partition layer is where all the metadata, the indexing, the detection of load and dynamically load balancing it happens. And finally, on top is the front ends that you communicate with your REST calls, your authentication, billing, metering, all of that happens on top of those 2 layers. So this is interesting because by having one common software stack, it really allows us to give you a common feature set, a very consistent look and feel for the programming and the APIs. And it allows us to also give you pass on the economies of scale that we get by mixing cold blob workloads with hot table workloads or queue workloads. So we can kind of mix all those workloads together, do it very efficiently. And it also allows us to give you all of these capabilities, for all of our offerings, right? So if you look at scalability, we have per account, we can do 500 terabytes of data, 20,000 transactions per second, and up to 10 gigabits of ingress or 20 gigabits of egress. You have multiple durability options. We're the only cloud storage provider to provide automatic geo-redundant storage, where your data is asynchronously copied from the one data center where you're writing to another data center at least 400 miles away. We also provide SLA guarantees on our availability. And we do have multiple access control and analytics capabilities, but I'll let my colleague Jason kind of walk you through those things with demos and other things. So Jason, over to you.
Great, thank you. So Vamshi sort of provided an introduction to the storage platform, as well as a walkthrough of how to actually get started writing your applications. One of the things I'm going to talk about is how to actually start thinking about preparing your application for when it goes into production. The last thing you want to do is build a cloud-scale application, put it in production, and not have processes in place for monitoring and or diagnosing issues when they do occur. You can imagine, at cloud scale, even 1 in a million operations failing. For our platform, would mean 6 operations failing every second. That would be a lot of dev time chasing down issues that could be spent sort of creating new features. So we obviously have extensive DevOps capabilities within our platform, and we've exposed a lot of those for you to actually use as well. So why do you have to think about it? Well, sort of there's 3 different sort of ways that you want to think about sort of monitoring. The first is if you're selling your solution to customers, you probably have KPIs that you've committed to your customers and or that you're actually committing, that you want to make sure that you're meeting. Secondly, you want to try to identify issues before your customers do. And thirdly, you've got the sort of service fundamentals, service health, service availability, performance, scalability, capacity, those sorts of things that you want to be tracking on an ongoing basis. So when you think about monitoring, there's sort of 2 main ways to actually think about it. The first is outside in. So this is where you basically want to actually have agents running on the outside of your application, performing synthetic transactions, simulating sort of your actual user's behavior. Microsoft has a tool called App Insights. There's also external products, Gomez and Keynote, that are very good for this sort of outside-in monitoring. Outside-in is also very good for actually isolating issues to network outages, because quite often you'll have a person in one region complaining about network latency. Very hard to diagnose, but these tools make it very easy. Then there's inside out, and this is what I'm going to spend the majority of the time talking about, whereby within your application, you've instrumented it such that you can actually monitor, raise alerts, and then investigate as necessary. The storage platform has 2 sets of capabilities, metrics and logs, that we'll walk through. Our client libraries also include logging that you can enable should you need to. At times, you may need to look at what's going on in the network, and we'll talk a little bit about some tools that are useful for that. And if you think there's actually issues with with a particular workload or its availability, Azure Portal has a service health dashboard. So the first thing I'm going to talk about is metrics. The easiest way to think about metrics is the equivalent to perfmon in a Windows Server type environment, whereby there's 40 different types of metrics that are available for blobs, tables, and queues that allow you to actually monitor the health of those capabilities. One of the key differences is that even though you may have our storage service has an awful lot of servers under the covers, we aggregate all of that information and actually provide it to you. The metrics are available in hourly and minute level views. The hourly is very good for taking a look at sort of trends over the last day, week, month, and so forth. The hourly, the minute level metrics are very good if you're actually trying to actually determine, drill into a problem. Both metrics and logs allow you to actually specify granularity, operation types that you want to log, and retention policies. Metrics are actually stored in tables. Logging information is stored in blobs. All right, so I'm going to switch over to the new Azure portal. And what I'm going to do is actually drill into storage accounts. The storage account that I've been running my test application on is over here, JHog Test 2. And what we're going to do is take a look. First of all, it provides at the top of the portal a little sort of summary information. One of the things you can see is that I've actually configured my account type for RAGRS. So this is sort of the model that Vamshi was talking about, whereby whenever I write to my primary location, it's automatically getting replicated to a second location. Plus, I can also read from that second location, which is very helpful when you're building highly available applications. And I'll walk you through some code that demonstrates that shortly. Now, I'm just going to collapse. The mouse seems to be playing up. I wonder if, interesting. The slide and the mouse do not get along. The slide. Let me collapse that. Yeah, put the slide sorter over there. What you can see here is a dashboard that is actually fully customizable. Right now, what it's actually showing is the total requests. And it's showing, right now, it's showing them for the last hour or so. But what I can do is edit this chart. I'm sorry, the mouse is misbehaving. And I can do a couple of things here. First of all, I can actually change the time range. So first of all, I have it set up right now for a customer. I'm drilling into a 15-minute period. But if I actually want to take a look at, say, past hour, I can also look at, like I sort of mentioned, there's 40 different characteristics of blobs or tables. I haven't been using queues, so that's why it didn't pop up there, that I could be looking at. Right now, I'm looking at total requests. I can save. Then I can actually see, we should actually see the data for the last hour. And you can see it was about an hour before the presentation. I was getting my demo ready, so you can see sort of a spike of activity there. Because I want this to be a dashboard, it's not just the number of requests that are interesting to me. One of the largest sort of areas where I've seen customers want assistance is they've deployed an application, their customers say it's performing poorly, and maybe it's sporadic. So here's a couple of counters that are well worth taking a look at. End-to-end latency and average server latency. What these metrics show you is server latency is the time that we actually spend performing an operation on our service. End-to-end latency actually tracks the time it takes from the client to establish a connection to the storage service, the time it takes to actually perform that operation, and the time to return all of the data to the actual client. So it's a really good indicator of when things may be going wrong on the network. So in this case, you can see here, the actual average time it took for our server to actually perform the operations was 5 milliseconds. The average end-to-end latency was 164 milliseconds. So you can see there's 160 milliseconds just of network time involved in that request. And that's actually not too bad. That was from the hotel, over a VPN, those sorts of things. But very useful tool for troubleshooting. The other thing that you can do is very useful for actually monitoring is you can actually create alerts. So an alert is where you want to actually create a condition, such as high latency alert, where I can basically specify that a specific metric, maybe average end-to-end latency, is greater than, let's say, 1,000 milliseconds over the last 5 minutes when I send an email to my administrators. So there's a good example of where you're trying to actually create a policy that allows you to get ahead of your customers. Rather than them having you call you up and tell them that something's going wrong, you can create a policy along those lines. So I've just done that. So that's a quick look at metrics. One thing I didn't mention was the analytics platform. Sorry. Analytics is not enabled by default. So the first thing we do recommend is while you're actually doing your development and you create your account, go into the portal and enable both logs and metrics. Definitely helpful when you have to start troubleshooting. So metrics allows you to actually observe the behavior of your application, your system. Sometimes just the metrics information on its own will give you a hint of what's going on. We sort of gave an example there. But oftentimes you may actually need to actually drill into log data to actually see what's going on. So that's where we have something called logs. Think of it in some ways as a sort of equivalent of IIS logs. Every single REST operation that's performed can be logged. We allow you to actually specify a subset of those. So, for example, you only wanted delete or updates to actually be logged. You could do that as well if you want to actually reduce the size of your log files. The log entries include sort of all the information that you would expect inside a log, the actual operation, the endpoint that was called, the time it took, the size of the message, all that sort of stuff. Very useful for troubleshooting. And what I'm going to do right now is I'm going to try to do this live. So you saw earlier, Vamshi was performing a set of operations against an endpoint. And what I'm going to do is use a tool called AZCopy, which is sort of think about this as a file copy utility that allows you to actually copy data from on-premises to the cloud, from the cloud back to on-premises. And in this case, what I'm going to do is actually copy all of the log files that were created while Vamshi was actually running his demo against demos 15 into my file system. And we'll see there. So actually, 84 files were copied. And hopefully, they will actually show up shortly on my C drive. There we go. And so they're actually copied into the respective sort of workload folders. They're copied by blob, by date, and finally, the log files are basically structured in sort of 5-minute intervals. You open them up, they're actually a little bit hard to actually do anything useful with. So one of the tools that we've actually spent quite a lot of time working with is a tool called Message Analyzer. So Message Analyzer is a free utility you can download. It actually comes from the team that originally created Netmon, which I'm sure many people have used. What this actually allows you to do is basically create a session, and what we can actually do is add files. And what I'm going to do here is logs, import all of the logs that we've just downloaded. Open them. In this case, it's actually a reasonably small amount of data, so we can just load it and process it. But if you actually had, like, say, a week's worth of data, you can actually use a start filter and an end filter to specify a start time and an end time, and then it would go through all the logs and only pull out the log entries that fall into that criteria. You can also establish a session filter, where if you wanted to actually have more advanced filtering, such as looking for all status codes of 300 or more, you could do that. Let's go over here. Once again, so let's actually import that data. And so again, what we've got here is just the default view of that data. And what we're going to do right now is actually choose, we've got a storage log view of that, which gives us like a strongly typed view of the data and the ability to actually query it. So we can actually, oops, mouse is misbehaving. So you can actually see now all of those entries that we've actually just imported available in this tool, which is kind of useful. But where it gets even more interesting is I've still got an awful lot of data, and I'm trying to actually work out why that error that Vamshi showed on the screen occurred. So what we can actually do is actually write strongly typed queries. So Azure Storage Log dot, let's look for anything maybe that has a status code of more than 299, because that tends to imply something unexpected is occurring. So what we've gone through now is actually filtered through all of the data. And if you remember, Vamshi also actually customized the client request ID. So we can actually see straight away there that the actual, the specific operation that failed is here. And we can take a look. It was a put blob operation. It actually returned a 409. So 409 is an error that's recurred when some kind of concurrency issues occurred. And so straight away there, you could actually have a pretty good sense of what was going on and sort of get back to your users. This tool is also very useful at finding patterns in your data. So we've basically got a number of different sort of best practices that we've identified, and you can actually search for them. Things like enabling that was mentioned. There's a rule in here for actually detecting if you should be enabling. One last thing that this tool is very useful for is we'll come back to that in a second. Let's go back over here. Okay, so we talked about metrics, we talked about logs. There we go. We also have client-side logging. So this is basically inside each of our client libraries. We have a consistent approach to actually doing logging. Very useful for enabling when you're actually trying to actually debug. The next thing you want to be thinking about is quite often, especially where you've got networking issues, if you're sort of getting sporadic network access from a specific region, you may end up using something like Wireshark or Message Analyzer, which allows you to capture a network trace at the TCP level, see if there's something wacky going on, lots of reconnects, those sorts of things. And what I'll do is right now, one of the challenges there is that you sort of end up with, I've got all this server-side log data, I've got this network shark, or sort of I've got this network analytics I've pulled together, I've got these client-side logs. You've got an awful lot of log information, and actually stitching that together is really difficult. One of the cool things about Message Analyzer is it actually allows you to correlate those log files together. So if you remember, we have that correlation ID that we actually pass in the client. It's actually also in an HTTP header, and it's also inside the storage logs. So what you can see is in this sort of pre-canned demo, I've already loaded all of the client-side logs from a test. I've already loaded the storage logs and a network trace. So I can actually go into a particular request, see the response. And I could actually jump in and start looking through the data. I could write queries. Again, not an overly useful view, though. So what I can also do is basically group the data. So I can actually group it by client request ID, at which point now what I actually see is a correlated view of the data. I have to keep that remote away. Where, for example, if you actually had a specific client request ID that you were looking for, you can then actually, you could search for it using the filter. Then you could basically see what was going on inside the client application, strongly typed again, so you could actually query against it if you wanted to, and so forth. So really useful tool for troubleshooting. And and that's the correlation that we just spoke about. All right, so that's sort of a couple of sort of things to be thinking about when you're actually thinking about planning your application for deployment. What I'm going to do right now is sort of talk through a number of different design patterns that you may also want to think about while you're designing your application. This is just a sample. We have an awful lot of other patterns that we've basically captured over the time. We've got available sort of either in samples or on our documentation page. And we've got pointers to those shortly. But a couple of these are new, which is sort of why we wanted to talk to them today. So we're going to talk about Application Layer Encryption. This is a capability that we've just released this week for our .NET client library and coming soon for other libraries. The ability to actually do direct data access using delegated authorization. This is a model that we've supported for a long time and our recommended model for many scenarios. The ability to do large-scale append operations, critical for big data logging scenarios, but also useful for a number of other scenarios as well. And then finally, I'm going to talk about how to build highly available applications using our AGRS. So let's jump into encryption. So this week we've released an extension to our .NET library that actually allows the library to automatically encrypt your data before sending it to storage. And then when you retrieve data, have it automatically decrypt that data. It integrates seamlessly into our current SDK. So for Blob Blobs, your existing APIs that you followed, you just have to add basically 3 lines of code. For Blob Blobs, we actually support full blob uploads. We also obviously support a full blob download. We also support range get operations on retrieval as well. For tables, we've got the ability to read, insert, and replace entities, including specifying what subset of attributes on an entity you want encrypted. We also support batch operations. Queues, obviously, each message is individually encrypted. So the funny thing with client-side encryption is a capability that probably everybody in the room could build themselves. But playing with crypto libraries is not really fun for anyone. And so that's why we've done the hard work. We've actually followed a standard enveloping encryption model. We've catered for things like key rotation. And we've basically designed it in a way where we've ensured that the actual format that we're actually storing the objects in an encrypted format, can be loadable from different language client libraries as well. Each object is self-contained. In metadata, we actually store the references and the actual algorithm that was used for actually encrypting. And if you're interested, all of the source code is available on GitHub. Now, one of the challenges with application encryption is it's all very well to encrypt all of your data. But a lot of organizations are worried that what happens if you lose the key? How do I decrypt my data? The fact is you can't. So one of the things we recommend is you want to actually be thinking about a key management capability at the same time as investing in encryption. So Microsoft this year has actually released Key Vault, which is a key management solution that allows you to manage, rotate, and monitor key access. Keys, and actually sort of another point for the client library encryption and for keys managed by Key Vault. Microsoft can never see these keys. So both of the solutions have been built in such a way where you can upload the keys and you can sort of rest assured that there's no way for us to actually decrypt your data. When you're using Key Vault for actually managing your keys, the master keys are actually protected at rest with HSMs, so highly secure and tamper-proof. Authentication for interacting with Key Vault requires AD credentials. And this also allows you to actually think about sort of separation of concerns. Ensure that the users who can actually manage your keys are different from the users who are actually running applications that are actually performing operations on data. The storage library that we just talked about, the extensions, they also enable Key Vault integration. So again, you can very quickly get up and running, and then if you want to actually have your keys managed by Key Vault, trivial. And that's what I'm going to sort of do a quick demo of right now. All right, so just for the sake of time, I've just opened up. When you actually download our latest client library, there's a pointer to samples that actually show blobs, tables, queues, and files being encrypted. I'm going to take a look. We'll just focus on the blob one for now. It's pretty straightforward. You can see the API is exactly the same as what Vamshi was just walking through. Basically, you create a storage account, you create a client, which sort of proxies the request of the service, you create a container, all that sort of good stuff. What we've done there is basically added 3 lines of code. The first code is an RSA key. So this is basically one of the extension points that we have within the application is that we can actually locally, you can choose to encrypt the data using symmetric or asymmetric algorithm, Or if you want to, you can have Key Vault for performing the actual encrypt and decrypt operations. And if we were using Key Vault instead of RSA key, we'd have this sort of Key Vault equivalent provider in there. Once you've actually created your key, in this case we're creating an RSA key, you then want to create an encryption policy. So basically, in this case, it's a blob encryption policy, and it's just referencing the key that we've just created here. And then finally, we have this request options capability where all of the storage operations already have sort of an extensibility point where you can, when you're actually performing a request, you can specify things, what location to get the request from, and so forth. All we've done is extended that to allow you to actually specify an encryption policy. And that's exactly what we've got here. So I will run this, but I will tell you encryption demos tend to be fairly uninteresting. But what we've got here is, so I'm running Fiddler in the background. What we can see here is was basically a number of different, so we basically uploaded the actual binary data. Then what you can see there, and again, everybody should be reasonably confident that that's not digestible. Then what you can see, so again, what we've done here is we used our upload blob capability. Under the cover, that performs a number of things. It actually breaks the data into blocks, and then it submits a block list, which is how we sort of commit the final blob. In the actual block list operation, you can see here that we've got some extra headers that exist. Let me just switch to a more readable view. You can see we've got this XMS metadata encryption data. And that's where you can see basically where I sort of mentioned that the data was self-contained. We've got the encryption mode, which says full blob. We've got the wrapped content key. And this is where it gets a little bit sort of tricky. There's actually two forms of encryption that are occurring. We actually encrypt all of the data using a symmetric key. Then we encrypt that symmetric key with the asymmetric key in this case, or it could have been that Key Vault was encrypting that. And what we have to do is store the encrypted content encryption key and a reference to the algorithm that was used for actually encrypting the content encryption key. And that's all stored in metadata. Again, we submitted it. We've got the GET request where we actually pull the data back. Again, it's encrypted, so nothing really interesting to see there. But the key here is anybody who's using our client libraries, trivial to get up and running. Take a quick look at tables are kind of interesting. Vamshi sort of showed you how you can actually use the table entity object to define your entities. One of the nice things we've done here is basically all you have to do is adorn sort of an attribute that you want encrypted with encrypt property, and then at that point it will be encrypted automatically under the covers for you. There's also a Key Vault getting started sample. This one does require a little bit more time because you've actually got to create your Key Vault vault, you've got to register your application, you've got to get some AD credentials, those sorts of things. So I won't run it through it right now, but the application's there, and there's basically everything you need to get up and running. So that's encryption. Thank you. Does that mean it's been a long time coming? So while we're on the subject of sort of security, we talked about sort of how to encrypt your data. Something else that's critical to think about is access control. So the storage service has three main means of actually performing access control. First of all, you can use a storage account key, and that's what you saw sort of Vamshi doing. This gives you full access to the data. You can actually create, you can update, you can also delete. So quite often, you don't want to have all of your end users, and you certainly would not want mobile devices to be using your storage account key because they're essentially untrusted. So we also have a capability called shared access signatures. Think about this as sort of delegated authorization, where you can actually create a token that grants a limited, restricted set of rights for a limited period of time. Very useful for a large number of scenarios, and we'll talk more about this one shortly. The third option we have is public, which is what Vamshi showed, which was for blob storage. You can also set a container to be public, at which point you can access it through a browser and you can do any read operation against it. So let's drill into shared access signatures, because these are actually the one that we recommend for most applications where security is important. There's actually a number of different capabilities you can do. First of all, you can specify what resources you want to grant access to. Containers, blobs, queues, tables. Within tables, you can also specify ranges of data. So if you're actually building a multi-tenant application and you want to have a different PK for different customers, you could actually grant SAS tokens for those specific key ranges. Very soon, we're also going to have account SAS, which basically gives you account-wide control to a storage account. Very useful for tooling companies. Anybody building a storage explorer right now, you have to ask the people for their full storage account key. Instead, you can just ask them for a SAS key that gives account access. permissions. You can obviously provide read, write, delete, all the different permission capabilities. You can also specify a validity time, start time, end time. Two other things that are coming soon, the ability to actually restrict access to a specific IP address. So very useful for financial services companies, for example, want this. They want to ensure that their employees can't go home and access data. If the application's only actually allowed to work from a set IP address, you can actually prevent that. Also the ability to lock down a protocol, HTTP or HTTPS. At the bottom, you can see the token is literally just a string of text. You add it onto the URL, and then that URL, you can basically then perform the operation against the data. So in this case, there's an operation against storage account. SE is basically the expiration time for the token. SR, which is highlighted red, is the resource type, and in this time, SSC, which is a container. And the SP is the permission. That's the write and the list capability. The string afterwards is the signature. The signature can only have been created by the storage account key, and we validate that on the back end, and that's how we determine that the resource is valid. So now the SAS tokens actually provide some interesting scenarios. So first of all, what it allows you to do is ensure that your clients can access storage directly. So if we didn't have SAS tokens and you wanted to actually have an access control strategy, what you would have to do would be build a data access layer on top of storage. And then the challenge would be you'd have to work out how to scale it as your user base grows. Pain in the neck, especially for these mobile and IoT scenarios where you've got very spiky, very large workloads. So what you can do instead is issue a SAS token to each of your applications. That allows those applications to interact directly with storage. Very, very easy for you. It's also suitable for untrusted devices, obviously. Also good for web and JavaScript scenarios. We have CORS support. CORS with the SAS token enables direct web pages to actually access storage directly. Also good for big data scenarios. You can actually issue a token that's only got the ability to write and read, not delete. So useful for logging, auditing, those sorts of things. Speaking of big data, one of the challenges we see a lot is the ability to actually log large amounts of data very quickly. So we've created a new type of blob called an Append Blob. This was actually created for the data lake product that you've heard about today, or this week. Because to date, if you wanted to actually append data to the end of a blob, you had to do two things. First of all, there was a series of APIs you had to do. You had to do a get block list, you had to upload a block, then you actually had to submit the block list. So there's 3 operations for every append. Kind of time consuming. The other thing was if you had multiple clients doing that, you then have to work out how to actually synchronize so that the clients don't actually overwrite each other's data. Very difficult to do. So we've got a new API called Append Blob, single operation. You literally just call Append Blob, and it's a single operation. Therefore, you can have tens of thousands of clients or a large number of clients writing directly. The APIs follow the same conventions as block capability, so it'd be very easy to get up and running. There's a quick code sample below. I won't demonstrate it because it's exactly the same as Blob Blob for all intents and purposes. The one final thing I wanted to talk about was designing highly available applications. So one of the things storage provides, and Vamshi mentioned, we're the only one that provides this by default, is the ability to actually have data replicated across regions. In addition to that, you can also specify that the second region enables read access. So if you actually build your application with this in mind, you actually get 4 nines of availability that we commit to by SLA. Our client libraries include retry policies. We have a default algorithm, which is exponential backoff. And what this means is that the actual client library allows you to actually specify primary, then secondary as its retry policy. It will first try a read or an operation on the primary. If that fails, it'll then go to the secondary. Which is a very sort of useful way for actually dealing with sort of transient faults in particular. So the retry operation is stateless. So it does mean that one thing you have to think about for catastrophic outages where you may lose the primary region, or if you're doing an application upgrade, which is a very common scenario, you might want to actually do 2 things. One, have your application work in a read-only mode, so at least some functionality is still available. But secondly, what you don't want to do is have every single operation try on the primary first, then switch to the secondary. So there's a pattern called short-circuiting, which is worth taking a look at. And I'll walk you through an implementation of that shortly. The other thing that you want to do when you're building an HA application is simulate server-side failures. And this is an ask we get a lot, so I'm going to show you how to do that right now. But the kinds of conditions you could run into production, you want to make sure that you've tested as you're actually doing development. Let's quickly touch on the short circuit pattern. So again, retry policies are ideal for transient failures, but short circuit pattern prevents an application from repeatedly retrying where there's more severe issues. Short circuit break can automatically detect when resources come back online and switch you back to primary, switch your application back to read-write mode. The fundamental, sort of the most important capability of taking advantage of here is within our client library, we have a retrying event that you can tap into. And so essentially what I'm doing is every time that retrying event is called, it means something's failed, we're doing a retry. I'm doing sort of some fairly simple logic where I'm basically just establishing a threshold, a certain number of retries in a certain period of time. I'm then going to switch the app to read-only mode, and I'm going to get all of my data from the secondary location. So I will demonstrate this quickly. I'm also going to demonstrate a way to actually generate the actual server-side faults. Let me move that over there. I've learned. So here's the short-circuiting pattern implemented. So again, it's basically just our standard block storage sample. I've got a retry count, which is basically just a counter. I've got a threshold. Right now I've set it for 1, which is basically just for the purposes of a demo. Then what I'm going to do is, once we switch over to the secondary and we're doing all of our operations in the secondary, you could do one of two things. You could have a time interval where every 10 minutes you might want to check if the primary is back up. That would require a background thread. The code would look a little bit more gnarly. So all I'm doing is every 20 operations, I'm going to see if the primary is back up. If it is, we'll switch back to primary. And so again, there's basically two main events I'm tapping into. One is the retrying logic, where I essentially keep count of the number of retries that have occurred. If we exceed a threshold, then what I do is actually change the default request options location mode to secondary, whereby all the operations will then go to the secondary. At that point, what we're going to do is basically every time an operation succeeds, where we're actually reading from the secondary, I'm keeping track of another counter, which is where we basically say, if after 20 operations on the secondary, I'm then going to actually switch back to the primary, and hopefully everything's got better. So I'm going to run this application. It's a very simple application. All it's doing is basically P indicates we're reading from the primary, and S indicates we're reading from the secondary. Now what I'm going to do is go into Fiddler. And Fiddler has an awesome capability called an autoresponder. And what I've done here is built a rule that allows me to simulate a 503, a server error. So you can see here in the URL right here, we've got JAHogTest2, which is our primary. If I go and enact this basically 503, you can actually see now, let me just go and pause the application. What Fiddler is doing now is basically intercepting all messages that are targeting this URL, and it's sending back a 503 message, which is something that typically only our server can do. So it's something that's very difficult in dev scenarios to actually simulate. But Fiddler is helping us do that. And you can actually see here, basically, we've got the red message where basically we intercepted the request, Fiddler is sending back a 503, at which point we've then got 20 reads that occur from the secondary, and you can see that basically secondary has been added to the URL. And then we basically try the primary. Because Fiddler was still running, we end up going back to the secondary. So let's actually continue the application. So we'll continue. And we go back here, and you can see here that basically the P's reading from primary, we introduced the error, that's when we switched over to secondary. If I go back to Fiddler now, basically disable the 503, what you'll see is we've gone back to the primary. So a really good example of how to actually build a highly available application, and also how to actually use tools like Fiddler to help you test your applications and not have to wait until production to actually see these types of issues. And we've got two last topics. Right. We'll talk about announcements and resources.
Try to go quickly here. So just kind of a quick summary of announcements. GA announcements, Premium Storage GA'd last week. Our C++ client library is GA'd as well now, so if you're using native code, go for it. Preview and things that are preview are coming soon. Azure Files is moving towards GA. We have technical support now available for it. We have new resource manager. You've heard a lot about it at this conference. Storage supports the new resource manager. Client-side encryption you saw. We have a Xamarin library that's released as well. And the Append Blob functionality you saw. SaaS improvements are coming soon. There's an iOS library coming soon. And the import-export service that allows you to import data into our service or export it is becoming available in Australia and Japan soon. In summary, kind of look at our documentation to kind of continue your learning from this session. We've kind of really worked hard on improving the documentation on Azure.com. We've also written a bunch of detailed white papers, like the one on table design, which is one of the most complicated things when working with Azure Storage. There's a 30-page document, but that's really kind of organized around what you need. There's stuff around monitoring and diagnosing that really goes more into detail along the lines of what we talked about today in the DevOps guide. And all our announcements, of course, always on the blog. We also pay, as an engineering team, very close attention to both the MSDN forums and Stack Overflow. Anything that comes in tagged right, we're looking at it quite regularly. And if you need to reach us on Twitter as well, we can be reached. So thank you again. Thanks for coming. Thanks for staying all the way to the end and a couple minutes over. And I'll leave you with the session feedback. We'll be.